Day 2 of determinants and inverses. As I told you by hand, at least so far, the only ones I'm going to ask you to do is a 2 by 2. Others can be done by hand. It just takes a whole lot more work because getting the inverse takes a lot of work. One of the methods is called expansion by minors. It takes some organization on your part. So let's try and leave the bigger ones to the graphing calculators and the technology to handle those. Okay, but of course that means that you need to well, pay attention. Basically, what you can do with any system of equations, and I'll just do this in general for you, is, let's see, I'll just make one up. You don't necessarily have to write this down. You can just follow along at this time. Because I can pretty much guarantee the answers to that are not nice. Okay. If you tried elimination substitution, would it still work? Yeah. Or if you tried graphing, it would still work, but not very nicely. And so what we can do is take this, what's called a system of equations, and turn it into a matrix equation. And basically that matrix equation is quite simple. Do you agree there's an understood 1 there and there? Right? So if you have them in order, do you agree I pretty much have the two equations in pretty much the same order? They're both standard form, right? You can just go ahead and take those coefficients, which are 2. This 1 actually goes right here, and this 1 goes here, and the negative 7 goes there. And I could take that times this matrix, and it would equal that matrix. Let me just prove that to you real quick. That system and this matrix equation are the same thing. So basically, we've taken two equations and turned it into just one equation. It's a matrix equation, but it is only one equation. Okay? But do you agree that this is a 2 by 2 and this is a 2 by 1? So should I be able to multiply them? Yes. And how big should the answer be? And how big is it? 2 by 1. And wouldn't I take this row times that column? And wouldn't that be 2x plus 1y? And isn't that exactly what that says? And same thing with the bottom. Wouldn't it be 1x minus 7y? And equaling 12? So the two things are exactly the same. But let me write it even more general. Let's say this is A. This is called the point matrix, if you really want to know what it's called, because it gives you x and y. It's a point. Okay? And this is called B. So do you agree that basically I'm taking A times that point matrix and it's giving me some B? That's really what that's saying. So if this was an equation, wouldn't you just try and get x and y all by itself? And which means is I've got to get rid of that. But unfortunately, with matrices, have you ever heard us say matrix division? No. But we can multiply by the inverse. And if we multiply this side by the inverse, we have to sneak it actually in here for it to actually work, otherwise the dimensions don't match up. Okay? If we do that, I told you the other day, kind of in passing, what you get if you take an inverse of a matrix times that matrix. Yes? Exactly. Or in other words, the matrices version of what number? 1. Right? And isn't that what I want out front? The matrices version of 1 is what you get, and let me show you why that's important. Right? That's what I get there. Watch what happens now. That row by that column, 1x plus 0y. So it basically just tells you what x is. And 0x plus 1y. It basically just tells you what y is. So all I have to do is do that. So now you know why we spend so much time taking the inverse, knowing how to do it. Because all you have to do is take the inverse of that coefficient matrix, that's what this is called, times the solution matrix. Boom, answer. And that's why it works. Okay, so let's try it. Here's a 2 by 2. Again, elimination or substitution might take a while. I'm not saying that these are going to be perfect. The best time to use this, you remember that one we did with elimination and substitution, and the answer was like 99 over 27 and negative 19 over something were the two values? That's when this is handy, because the one time you hit that is at the very end. That's the one time that fraction shows up. So let's get the matrix equation. 5, 4, 3, negative 5. And I will ask you for the matrix equation from time to time, so make sure you know how to get it. But again, you've gone from basically having two equations and two unknowns to having one equation, and basically consider that point matrix as one unknown. I want to find the point matrix. And if I can find it, I'm done. Okay? So again, this is kind of considered A, and that's kind of considered B in normal notation. So if I could just take this side times the inverse, again, I'm not asking you to actually sit there and multiply that out, because we know the answer, right? If we did it right, that's what it's going to be. So why waste your time? And then over here, we know we're going to get this, and so I have to do the same thing over here. So I better, do we already know B? Done. Do we know the inverse of A yet? No. And so that should probably be something we go to figure out. We know that, we don't know that. And so let's do, here's A, right? Here's A sitting right here. So to find the inverse, what's always that first step for finding an inverse? Determine it, because we have to determine, can I actually take the inverse? Because maybe I can't. All right, well, let's find out. So what is that, negative 25? That's the positive diagonal, right? Here's your negative diagonal, so minus 12, right? So what is our determinant? Negative 37. So does this matrix have an inverse? And we're kind of happy about that, because if it does, we can solve it. If it doesn't, well, maybe you'll figure out what that means. So you do 1 over determinant, correct? And then what do you do? Go back to your original matrix, take the positive diagonal, and do what? Switch them. What about the negative diagonal? What is that right there? The inverse of A. So that's A to the negative 1 right there. So I have to take that times B, which is right there. Now, you have two choices at this point. You could take this negative 1/37th and multiply it through that part of A there, and then multiply the matrices. Or you can multiply the matrices and then multiply by negative 1/37th. There's probably one way that's way easier than the other, and that's multiply the matrices first. Okay? So you take row by column. Do you see that if I put this matrix first, that it's not going to work? Because it'd be 2 comma 1 and or 2 by 1 and 2 by 2, not going to work. So you go negative 5 times negative 3 plus negative 4 times negative 24. And then you got to do this one. So you do negative 3 times negative 3 plus 5 times negative 24. And that is almost your answer. You're close. Is it all right for me to erase this matrix equation down here? Everybody kind of understands where that's coming from? I think. All right, what do we got here? Better do a different color. 15. And that's a little bit bigger, but I think you can handle that. It's going to be a positive. 96, yep. So you add that together. It's not that hard. Close. 111. This one is, what, 9? 100 and, well, it's actually minus, right? Plus or minus? Okay, or minus. 120? How come that's not the answer? Yeah, basically, and I like how whoever just said that, somebody said we haven't divided by negative 37, and isn't that really what we're doing? Multiplying by negative 1/37 is the same thing as dividing by negative 37, right? So take, and you might be surprised, but you take 111 and divide by negative 37. You remember this? This would have been a perfect example of when that one problem was horrible answers. And the first time that you would have hit it was now. Was the first time you would have hit that horrible 99 over whatever that was, 18 or whatever that problem came out to be. Well, it wouldn't be 18 because that would simplify. But 111 over that is, careful, careful, negative 3. Positive divided by negative. And then the bottom is 3. And really, what does that equal? Negative 3. 3 is the matrix, and it equals the matrix xy. So what's the x coordinate of the point where these two lines hit each other? It's negative 3. The y value is 3. I don't care if you leave the answer as a matrix or if you write it as an ordered pair. It does not matter to me. Now just imagine how powerful this is if they get bigger or more dimensions. What if you start dealing with a third axis, the z-axis? Graphing gets even more complicated. Elimination and substitution also get more complicated, but technology is really good at using matrices to solve those. Or what if you had a fourth dimension, a fourth axis, or a fifth? That's when technology is very helpful. And if you show me you can do it by hand, I'll show you how to do it on calculators. Yes? Exactly, because we're always going to be dealing with basically a 2 by 2 that's times a 2 by 1, because it's a point matrix, which ends up being a 2 by 1. What will happen is when we get a 3 by 3, it'll be a 3 by 1, and then so it's a 3 by 1 in the end. Okay, because they'll always, whatever these two are, will always match up because they're supposed to. I would like you to try this one right now on your own with no assistance. All right, let's take a look. Okay, start with a matrix equation. It's probably the safest way to start. It is very easy to not recognize that's a -1. Right? Take it times xy, that's the point matrix, and you will get the solution matrix. And basically, let's face it, we know that to get this, at least if you were paying attention at the beginning, I have to take the inverse of A times B. So let's find the inverse. Inverse of A, you got to find the determinant. -6 minus 7 is a -13. 1 over -13. And now you have to take the positive diagonal and switch their location and change the signs on the negative. So this right here all together is the inverse of A, which you then have to take times B, which is right there. Well, that should probably be right there. Okay. And I'm running out of room again, so we'll get rid of this. So if you do that, it's smart to do that first. So you take -1 times -9, and you get 9. And then you add whatever you get when you take -7 times 5, which is a -35. Okay? And then you take, maybe we'll put a box around it this time to show the difference. -1 times -9 again, which is 9. And then 6 times 5, because it's second one times second one, so it's plus 30. But if you just finish that, that is not your answer because you still have that. Okay? So you take 9 and then minus 35, or -35 plus 9, whatever way you want to do that, and you get -26, which actually is a pretty nice number, really. And then what, 39? And we have a 1 over -13 out front. So in other words, it's really dividing by -13 is really what you're doing. And so your point matrix equals negative divided by a negative is a positive, and that is 2, and then this is a -3. Or again, x is 2, y is -3, so if you want to, you can write it that way. Now again, I gave you two that worked out fairly nice, and it works well for those too. But again, when they're hugely helpful is when the answers really aren't all that nice, because it gives you both answers all at once instead of finding one bad answer, and then you have to substitute that bad answer back in to get another bad answer. Right? So any questions? Again, I'll just give you the 2 by 2 for now. Nothing?